This is now our second example, whereby when you check on our denominator here, it involves a quadratic equation. When you've been given a function that involves a quadratic equation like this one, the first thing that you need to do is to simplify the quadratic equation. And by simplification of this quadratic equation, we are going to have product, the coefficient of a we multiply by c, which is going to be -3, sum, it is a positive of 2, and factors, the two possible numbers that when we multiply them, they must give us a negative of 3. And when we add them, they must give us a total sum of 2. To mean that those numbers can be 3 and -1. Because when you take these two, you must have a product of 3. On adding them, you must get a sum of 2. And now we are going to have s squared. We add to 3. We subtract 3s. We subtract from s because here we are having a negative of 1. We subtract from 3. Come and do your factorization. In our first bracket, we have a common factor of s into s. We add to 3. Because when you take s, you multiply by everything. You must get what we are having in this bracket. We subtract from 1. S. This negative is going to affect the negative within the bracket. We are going to have 3s. We factor what we are having outside the bracket, and then we come and take one of the bracket, s plus 3. We've done our factorization. Up to this point now, we've done our factorization. And now we are going to have the inverse Laplace transform of 11 we subtract from 3s all over s we subtract from 1 into s we add to 3. And we can rewrite everything in form of now the partial fractions, whereby we are going to have the inverse Laplace transform of a all over s we subtract from 1, because this one is a linear first order equation. We come and add to b all over s we add to 3. Let us now use cover-up rule to get the values of a and b. For us to get the value of a, s we subtract from 1 will be equals to 0, to mean that s, we must get its limit. So we are going to have 1. And we can come and we can come and say that limit s approaching a positive of 1 into 11 we subtract from 3s all over. We are going to use the cover-up rule to mean that we are going to cover up our first term here, and we are going to have a s we add to 3, which will be equals to, now we insert our limit to the term of s. 11 we subtract from 3 into 1 all over 1 we add to 3. 3 we subtract from 11 we subtract from 3. We are going to have 8. And on the denominator, we are also going to have 4. To mean that the value of a is equals to 2. Let us now get the value of b using the cover up rule. B, we are going to have s we add to 3 is equals to 0, to mean that s will be equals to a negative of 3. Limit s approaching negative 3 into 11, we subtract from 3s all over. We cover up our first function here, s plus 3, and we are going to have s we subtract from 1. Here we are going to have 11, we subtract from 3 into negative 3, because that is the term of s. All over negative 3 we subtract from 1. 11, here we are going to have a positive of 11, here we are going to have a positive of 9, to mean we are going to have 20 all over a negative of 4. The value of b is equals to negative 5. Let us get back now to this point, whereby we say that it is the inverse Laplace transform of a all over s we subtract from 1, we add to b all over s we add to 3, which is equals to, the value of a is equals to 2 all over s, the inverse Laplace transform of 2 all over s we subtract from 1, we come and subtract from b, which is equals to 5 all over s we add to 3. We can now insert the inverse Laplace transform to each and every function here, and we are going to have 2, the inverse Laplace transform of 1 all over s we subtract from 1. We come and subtract from 5, the inverse Laplace transform of 1 all over s we add to 3. From this point now, we agree that exponential positive or negative at is equals to 1 all over s, negative or positive of a. This one was from the first principle. We derived this to mean that now we are going to have our answer as 2. Here now, we are moving from this point back to our answer. And we are having, on the denominator, we are having s we subtract from 1, to mean that we are going to have exponential t, because when it is a negative here, we are having a positive of a, and our a is equals to 1t. We come and subtract from 5 exponential. On the denominator, we are having a positive, to mean that here now we are going to have a negative of 3a, which is equals to 3t. And this is now the inverse Laplace transform. When you work out the inverse Laplace transform of our function here, you must get this answer. And by using the first principle also, you can work out this example to end up with that function here, to end up with this function here. And this is how you go about the inverse Laplace transform of a function like this one.